Over time, many sculptures and reliefs experience changes like significant losses. Sometimes the original appearance can be discovered in historical photographs or archives, but only if they are available and also in good condition. The problem here is that in the case of plaster reliefs, historic photographs can show the object only two-dimensionally, whereas the depth effect is lost. And sometimes, when losses have been filled and parts have been added, it's not always possible to reconstruct exactly how the additions are located within the object and what has been preserved from the original substance, like in this case. The Augustinermuseum Freiburg in Germany presents a polychrome stucco relief from the late 15th century, which shows the adoration of the Magi, but only with 2 of the 3 kings. Over the centuries, the kneeling king in the center in the foreground was lost. When the missing section was restored in the past, the lost king was not reconstructed. Instead, the addition was adapted to overall form of the relief. The archives of the National Museums in Berlin contain a historical photograph of a comparable lost stucco relief, which shows the same arrangement of figures, but with an additional king in the foreground. In this case, 3D model visualization and more specifically computer tomography can provide clarity. With the combination of computer tomography scans and 3D digitalization procedures with non-commercial software, newer additions could be identified, digitally removed and exported as a 3D model. This project is part of the research for my master thesis in scientific conservation at the University of Applied Science and Arts at Hildesheim, Germany. During my study, I specialized in 3D digitalization, digital reconstruction, computer tomography, and ethical principles for the handling of digital reconstructions. My name is Salome Hunziker. I'm a freelance conservator and lecturer for 3D scanning and digital reconstruction from Germany. And this is a short presentation of my IAC poster, 3D visualization and reconstruction with computed tomography. Scanning and reconstruction of a polychrome stucco relief. At the Technische Universität Munich, the relief was first scanned in 3 parts using a high-resolution micro-CT scanner for technological research. For the generation of a 3D model, the relief was scanned in 1 pass using a helix CT for human medicine. In both scans, grayscale 2D cross-section images from all 3 axes were generated. To view and evaluate the CT images, we used a free application called 3D Slicer, which is developed for image analysis in the medical field. The software can display the cross-section images as a point cloud 3D model, and that model could be edited and analyzed directly in the program. For the technological research, the evaluation of the data using the point cloud 3D model brought many advantages. To display the object without the additions, we used a process called segmentation. Segmentation is the marking of areas in the cross-section image which belong to the original substance according to the gray value range. For the segmentation in this case, all cross-sections of the relief were viewed individually and the areas were marked manually. A simultaneously generated real-time 3D visualization provides direct visual feedback to guide the user through the segmentation process. The marked areas in the cross-sections were later exported as a 3D polygon mesh. Manual segmentation can also be prone to errors if certain grayscale ranges are misinterpreted or the marking is not carried out properly. After the segmentation, the lost king was remodeled according to the comparable image. The king was first modeled manually, then digitized by structure from motion, post-processed in a 3D graphics program Blender, and fitted into the loss of the middle in the segmented model. After that process, we exported the relief and remodeled king as two separate 3D models. We also used the data to generate a full-size 3D print, which shows the remodeled reconstruction and also the relief without the segmented parts.